Okay, guys, Timmy coming at you. And today, what I'm going to do is I'm going to try to explain to you some of the major components of blood. If you took my advanced anatomy class, I explained to you that the blood is basically divided into two parts: the plasma, or the watery part of blood, and then the formed elements of the blood. And what I want to do is I just want to be a little more specific, drill down a little bit and explain some of that stuff. So basically, blood has some major components, right? We know that there's red blood cells, and we know that red blood cells are involved in oxygen delivery, right? We know that. At least we should know that, I think. Hang on, got problems again. Right? So they're involved in oxygen delivery to the cells. So if you lack red blood cells, or you have a lower red blood cell count than normal, you are referred to as anemic. Now, from the previous unit, we talked about the immune system. We know that white blood cells are intimately involved in the immune system. And remember, one of the primary functions of the immune system is to produce inflammation. And then you have platelets, and platelets are those little things that are initially involved in the formation of a clot. And then you have the watery part. So what I'm going to do is I'm going to get into some of the problems that you see specifically with red blood cells. And there's some measurements you have to understand too, like hematocrit. Hematocrit is the ratio of red blood cells to plasma. So when they do a CBC, they look at your total red blood cell count, but they also look at the ratio of red blood cells to plasma, which is referred to as your hematocrit. Now, look, we talked about this a little bit. We know that especially in adults, that blood cells, whether they be red or white, are formed in the bone marrow, and they start out as these hematopoietic stem cells. Now, red blood cells, baby red blood cells, are called reticulocytes. So when a red blood cell is born, right, it actually is bigger than a normal red blood cell. So when a red blood cell matures, it actually loses some volume. Now, reticulocytes can be important to measure if you think someone is bleeding. So for example, if their total red blood cell count is low, and they have no history of any active bleeding, they didn't cut themselves, or their period wasn't really bad, then what a doctor will do is look at a reticulocyte count. And if the reticulocyte count is elevated, then that means that the bone marrow is pouring out these baby red blood cells in an attempt to maintain the actual number of red blood cells. So an elevated reticulocyte count means that you're bleeding somewhere. And the most common place to bleed and not know that you're bleeding is your GI tract. So if we look at that, and we look here, here it is. So if we look, you have that hematocrit that I was talking to you about, right? Where it is the ratio of red blood cells to plasma. So if you look, here is a CBC with a differential. Now, here is the red blood cell count. This is the total red blood cell count. Now, if it's lower than normal, then you are anemic. And there's 20 different anemias, and I'm going to concentrate on just a few. So the other thing that you would look at too is you would look at the amount of hemoglobin that's present in each red blood cell. And then you're going to look at the hematocrit, which is the ratio of red blood cells to plasma. So in anemia of any cause, what you're going to see is you're going to see a lower than normal red blood cell count. You will have typically a lower than normal hemoglobin, not always, but typically. And then a hematocrit, which will be lower than normal, because remember, hematocrit is the ratio of red blood cells to plasma, right? And if you're losing red blood cells for whatever reason, then that number is going to be lower. And assuming that the plasma stays the same, that's going to lower your hematocrit. So let's look at this. First of all, when red blood cells are formed, we know that you need iron. Iron is part of the hemoglobin molecule, and it is where oxygen directly binds in order to be transported down to the cells of the body. So the most common type of anemia is iron deficiency anemia, and it's much more common in women than men because women have a period once a month where they're losing red blood cells and iron. So one of the ways that a doctor can determine if it's iron deficiency anemia is, first of all, if their red blood cell count is low, then what the doctor wants to look at is they actually want to draw some blood and they want to actually measure the iron that's in the blood. Now, iron is transported and stored not by itself. Free-floating iron will kill you, so you don't want that. You want to go to gateway. So there has to be ways to transport iron around in the blood, because you know that you store iron in your liver, but you make red blood cells in the bone marrow. So somehow that iron has to be stored in the liver. And then when it's needed to make new red blood cells, it then gets transported from the liver to the bone marrow. So the two things that you need to understand are how iron is actually stored, and then how iron is actually transported in the blood, right? Now, I'm going to go over this just real quick. As you know, I should probably make this red too, make it more legit. Red blood cells live about 120 days. And inside a red blood cell, you have that big protein hemoglobin. And embedded in the hemoglobin molecule is iron, right? And each hemoglobin molecule has 4 atoms of iron, and each iron atom is capable of transporting 1 molecule of oxygen. But we also know that inside a red blood cell, you just don't have 1 molecule of hemoglobin. You have like 250 million. So basically, a red blood cell is a cell membrane with a ton of hemoglobin dumped into it, right? Now, red blood cells live about 120 days. So when they die, they go to really one of 2 places. They either go to the liver or they go to the spleen. Now, the first thing that has to happen when a red blood cell is dying and then ultimately destroyed is the red blood cell membrane ruptures, and then it reveals the hemoglobin molecule. So there are enzymes inside the liver and the spleen that will begin to break down that hemoglobin. So this is what happens. The hemoglobin is broken down, and I'm going to take this really slow, to heme and globin, right? And as we know, the heme portion carries the iron. Globin is a fancy word for protein. And we know that proteins are made of amino acids, right? Chemically bonded together. We learned about that. The heme portion then, but through a series of enzymes, is broken down into iron and this stuff called bilirubin. And as you know, bilirubin has a yellowish color. That's why if you look at an old bruise, initially it is red or maybe even like a little purplish. And then as that bruise gets older, it becomes kind of a yellowish green. That is the red blood cells that were released when you ruptured the blood vessel. And then those red blood cells are getting broken down to bilirubin. So the bilirubin in the liver then is converted to bile. And then bile gets stored in the gallbladder, and that helps you digest fat. So it's the iron that I want to talk to you about. All right. Now, inside the liver, iron, again, you don't want this free floating. So it has to be stored, and it's stored with a protein called ferritin. So ferritin stores the protein. Stores the iron. Now, you got the iron in the liver, but where do you make the red blood cell? Well, you make it in the bone marrow. So there has to be a way of transporting that iron to the bone marrow, right? Cells of the bone marrow. And that is accomplished by a protein. This is terrible. That has little seats on it. And this protein that actually transports iron around is called transferrin. So transferrin, transport, is the protein that transports iron around. Now, if someone is anemic and a doctor wants to determine if the anemia is caused by an iron deficiency, then the labs that they're going to draw are these, right? They're going to look at, obviously, their red blood cell count, right? Then they're going to look at the amount of hemoglobin present in each red blood cell. Globin, right? Then they're going to look at the hematocrit, which is the ratio of red blood cells to plasma. Then they're going to look at the iron level. Now, in people who have iron deficiency anemia, they're going to have a lower than normal red blood cell count. The amount of hemoglobin will be low, and the reason the amount of hemoglobin is going to be low is because in order to make hemoglobin, you need iron, and your hematocrit will be low. Your iron will also be low. Now, look, the body does stuff that makes sense. When the liver makes ferritin to store the iron, some of that ferritin will be released into the blood. So remember, ferritin stores iron. So they will draw a ferritin level. And that ferritin level will be low. If you don't have a lot of iron to store, then you don't need a lot of ferritin, and therefore the liver won't dump a bunch of it into the blood. Then you also look at your transferrin level. And that's the protein that transports the iron around in the blood. Now, look, your bone marrow doesn't know that you have low iron. So basically what happens is if you don't have enough iron being transported to the bone marrow, then you're going to increase the amount of transferrin. So maybe you don't have enough transferrin to transport that limited iron supply. So the transferrin level in the blood is going to be elevated. Then the other thing that they do is they do what's called a total iron binding capacity. The total iron binding capacity looks at transferrin. And remember that transferrin is the protein that transports iron around in the blood. So what they do is they draw your blood and then they look at your transferrin level. Now, your transferrin level may be elevated, right? The protein itself. But what they want to know is they want to look, I'm going to try and draw a better bus this time. Right? So you got these seeds. And what they want to know is how much iron is actually bound to transferrin. So let's say that you have low iron. That means transferrin is not going to be transporting a lot of iron. So they draw the blood, they separate out the transferrin, and then what they do is they will actually sprinkle iron on the transferrin. And if a lot of iron binds, that means that the transferrin wasn't transporting a lot of iron because a lot of it got bound. So from a lab perspective, to diagnose iron deficiency anemia, the iron will be low, the transferrin, the protein that stores the iron, is going to be low. The transferrin that actually transports it around to the different body parts, especially the bone marrow, that's going to be elevated. And then the total iron binding capacity of transferrin is going to be elevated. Why? Because even though you got a lot of transferrin, it's not transporting a lot of iron. So the amount of iron that actually binds to transferrin is going to be high. And that's how you diagnose iron deficiency anemia. Now, some of the, and like just intuitively, you should know some of the problems associated with iron deficiency anemia, right? I mean, remember that the major function of red blood cells is to transport oxygen down to the cells of the body. So what are you going to see? Whoops, you ain't going to see that. You're going to see they're going to be fatigued, right? Always complaining of tired, right? Being tired all the time. Hang on, I got it somewhere. Right? Skin's going to be pale. And watch. The body does stuff that makes sense. If you don't have enough red blood cells to send to all of your body, then you're going to send what red blood cells you do have to the major parts of the body that need to keep you alive. Shortness of breath. Remember, when you have low oxygen saturation, then that is going to stimulate breathing. And then you're also going to be tachycardic because lack of oxygen will stimulate the sympathetic nervous system. Elevated blood pressure for the same reason, right? That's going to stimulate the sympathetic nervous system. Fatigue completely makes sense, right? Decreased appetite. The reason for the decreased appetite is because of the increase in sympathetic drive. And if the anemia is severe enough, you're not going to be eating because you're trying to maintain blood flow and oxygenation to the very important parts of your body. Now, and that can also lead to heart failure in really, really, really severe cases. And then they get that chelosis. That's the cracking around their mouth. I think I got a picture of it right here. they get these fissures here. And then they get that cholionichia. And that is basically where the nails become like, you can see the ridges in them. And the base of the finger, this area right here, becomes like depressed. And that's a classic sign of severe iron deficiency anemia. And what's really kind of weird, and this is this has nothing to do with treating that iron deficiency anemia. They developed this condition called pica. And pica is where you crave, you'll chew ice. In some cases, people will actually eat dirt or clay, none of which has a lot of iron in it. So that's a sign of pica, or I'm sorry, anemia. And then the treatment is, well, iron, or find out what's causing the iron deficiency to begin with. Is it some abnormal bleeding, especially in the GI tract, or is it heavy periods? And if it's heavy periods, some doctors will place women on birth controls, not so much to prevent pregnancy, but rather to treat anemia. And then you got to give them iron-rich foods. And remember, the vitamin C increases the absorption of iron from the gut. So that's important. So that's iron deficiency anemia, right? And they love in clinical talking to you about those labs. So the total iron binding capacity, you should understand, transferrin, right? The serum iron levels, the free floating iron, and then the ferritin, and how that works. All right, so I hope that helped.